Hi, everyone. Thank you so much for joining us today. Can you hear me okay? Okay. You need me to speak up a little bit? Okay, yes, sir. So my name's Emily Bowers. I'm the Director of State and Local Engagement at the Green Building Initiative. I'm very happy to be with all of you. It's been a real joy being able to plan this with everyone in Utah. We've been really looking forward to being here. It's a nice reprieve from the hot Atlanta weather that I live in currently. So it's just a real pleasure. Today we're going to be going over who we are, what GBI does, and our green building certification pathway, Green Globes, specifically Green Globes for new construction. If you have any questions, I hope this is collaborative. Please let me know. I can reiterate those to all of you and we can kind of tackle this together. All right, just some housekeeping items. Because this is an AIA registered course, you do receive one learning unit by being at this presentation today. So if you haven't given us your number, feel free to flag me after this, or Jacqueline. We'll be happy to make sure that we have all of that in place. Or if you'd prefer, you can email training@thegbi.org and we'll make sure that you get all the credit that you need for being in attendance today. All right, and so these materials are copyrighted, I have to say that. However, GBI is a big fan of transparency. We share a lot of our materials, so if there's anything that you want more information on, just let me know. I'm happy to share. We have a lot of really cool tools that we're gonna dive into today. All of those are accessible on our website, but just let me know and I'm happy to share whatever you need. All right, and lastly, just the last housekeeping item, because this is AIA registered, I have to read our course description. So this course is intended to design and construction professionals interested in third-party sustainable building rating systems. It provides an introduction to the Green Building Initiative, or GBI, and an overview of Green Globes for new construction. So we're also going to be discussing our ANSI accreditation process, but let's dive into the fun stuff. Okay, so GBI is a 501c3 nonprofit organization, and our mission is to mitigate climate impacts through the built environment. One theme that you'll see throughout the duration of this presentation is that we really believe in better buildings together. It's a core tenet of who we are as a staff, as an organization, as a board, but it's also baked into our Green Globe certification. So green building is not a one-size-fits-all model. I mentioned that I'm the Director of State and Local Engagement, so I work directly with a lot of state and local officials, and every jurisdiction is unique, every state and municipality is unique, and so we really think that every building can be doing something to be as sustainable, resilient, and efficient as possible. Our programs exist under two different umbrellas: Green Globes that we'll be discussing today, as well as Guiding Principles Compliance, which is a verification for the federal government. We work with entities like the DoD and the VA. And so if you have any questions, if you're doing any sort of federal projects and you want some more information on that Guiding Principles verification, just let me know and I'll walk you through that, or I'll kick you over to our national affairs person who's able to speak to that in greater detail. All right, so this is a slide that I love to share because as of 2022, we have certified over 500 million square feet globally. I don't want to do a cartwheel here, but if I could, I would. We're very, very pleased to see that. 3.1 million square feet of this 500 million has been certified right here in Utah. So we already do have a presence in the state of Utah. So with that being said, we have 500 projects that are currently in progress, which equates to about 97 million square feet. And then we've certified 975 projects through that Guiding Principles Compliance verification, which is our federal system. Okay, so I don't know how many of you work for the state. If you do, you understand how arduous the public comment process is. Whew, I used to work for the state and I hated all of the public comment process, but now it's so much fun. That really speaks to our ANSI accreditation, which is a very heavily guided consensus body project. We update Green Globes for new construction and Green Globes for existing buildings every 2 years. And as we're updating those systems, we're in a constant consensus body update, so we're making sure that we're bringing to market the most up-to-date standard, and we're working with subject matter experts to receive that ANSI accreditation. We started this process in 2005, and that led us being the very first green building certification to be ANSI accredited. So it's something that we're very, very proud of. It's not something that other green building certifications go through the links of because it is quite arduous. And just to speak to that a bit more, when we released Green Globes for new construction in 2021, over a 2-year process, we had over 100 meetings. We had 219 comments given to us about our standard, 86% of which were accepted. We had 16 different subcommittees and task groups, and in a 2-year process, we were able to work with 500 different groups that were able to have direct input on our Green Globe certification. So it is a very, very collaborative process, and we really take to heart what subject matter experts and practitioners have to say about what we're releasing to market, and we do this every 2 years with both of our programs. Okay, now we'll talk a little bit more about the Green Globes rating system. So what is Green Globes? Where do we come from? What are we doing today? And what does our future look like? So Green Globes was birthed out of Canada. I'm not sure how familiar you are with the BREEAM certification, but that is what we came from. In 2004, Green Globes was licensed for use in the United States market, and by 2013, the federal government had deemed Green Globes as a recognized and recommended program, which is a huge win for us. In that federal recognition, we were recognized as equivalent to the USGBC's LEED certification. We're the only 2 green building rating systems that are acknowledged by GSA, and they acknowledge us as equivalents to one another. In 2017, we obtained the global rights to administer Green Globes globally, and by 2019, once again, the federal government had deemed GBI's Green Globes as a preferred, recognized, and recommended program alongside LEED. So what does the future look like? We're right now undergoing a 3-year plan where we're expanding in different markets. In the last few years, we've really been focused on expanding in Latin America, so we're doing that currently, which is very exciting, but we're also looking at the different designations assigned to Green Globes. So we're rolling out a health and wellness designation that looks at the whole life cycle of a building and the occupants, and we also are working on a net zero protocol right now that's going through consensus body, and we're gonna roll that out quite soon. So we're doing a lot. We also work with different ESG services, so really trying to take this as holistic as possible and not just focusing on new construction and multifamily, but the life cycle of the building and the occupants that are inside the building, which we all learned in the last few years with COVID. That's quite important to look at the health and wellness of the folks who are in the building. All right. So I just put a few slides together to show who we work with, who recognizes us. We do a ton of work with Fannie Mae and Freddie Mac through our Green Globes for a multifamily system. They're great collaborators of us. I mentioned that we do ESG services, and we are a Tier 1 certified Green Globe system and Green Globe certifier through GRESB. And in 2021, we were recognized through the community standard with the International Well Building Institute. So if you're familiar with the WELL standard, they also recognized us. Okay, so one question I get often is like, what buildings can go through Green Globes? Like, what exactly does your footprint look like? And we really can certify any multifamily or commercial space. The only area that we don't certify is single family residential. So I look to see what different programs and portfolios and buildings are going through Green Globes right now, and I pulled this list. So we're doing work with a lot of data centers right now, specifically out of Illinois. We're working in laboratories, we're doing a lot of colleges like the beautiful one we're in now, hospitality, so we really have a large reach. I love going to Las Vegas because when you ride on the Las Vegas Strip, every hotel and casino has been Green Globe certified, but about 3 blocks down, there's a Whole Foods and a 7-Eleven convenience store that's also Green Globe certified. So that really just speaks to the varying buildings that we work with. So we're also recognized across government and industry. I had to give an homage to my University, Georgia State on here, so that's why I snuck that in, but they're also Green Globe certified. We've done a lot of work. I mentioned Whole Foods, obviously with the federal government through Guiding Principles Compliance, but this is just a brief snapshot of the folks that we've worked with recently. I also like to point to Amazon because we're doing a lot of warehouse certification. Those warehouses are normally not in metropolitan areas, they're in more rural areas. And so they don't have things like access to public transit. There's a lot of credentials that they wouldn't meet in a traditional green building certification system, but we're able to meet them where they are and achieve certain resiliency factors through things like warehouses even in the most rural areas. Okay, so Green Globes exists under 3 different assessment and certification programs: new construction, which we'll be focusing on today, sustainable interiors, as well as existing buildings. If you're doing any work with sustainable interiors, or if you're more focused on existing building or retrofits, let me know. I'm happy to share more information about that afterwards. All right, so looking at Green Globes and our scoring protocols. Is everyone with me? Y'all awake? Okay, great. So each Green Globes program and protocol is based out of a maximum of 1,000 points, and criteria is weighted according to environmental impact. So we don't have any prerequisites to go through Green Globes, which is quite unique. You need to achieve at least a 35% to achieve 1 Green Globe, which you see on the screen. We have 1, 2, 3, and 4 Green Globes. And one thing that's really unique is if there is a municipality or a building or a state that wants to make sure that Green Globes is written into the work that they're doing, maybe their ordinance or their code, you have to meet jurisdictional requirement in order to take your building through Green Globe certification. So for example, if you lived in Timbuktu and they had a very, very high ASHRAE 90.1 standard, we would make sure that you met that and that you're not getting around it just by certifying your building. So we really try to bake in the jurisdictional requirement so it's very holistic, and we're working with the community to uphold the standard that they have in place. Okay, so I mentioned that we have 3 different programs under Green Globes. Today we're going to be focusing on new construction, and there are 6 different assessment areas under new construction: project management, site, energy, water efficiency, materials, and indoor environment. And this is our point allocation for all 6 assessment areas. Again, this is out of 1,000 possible points. You might notice that in the diagram, the 2 most heavily weighted are energy and water efficiency. That never changes. So while we don't have any prerequisites, you really have to achieve optimal amounts in energy and water efficiency for certification. Okay, diving into the fun stuff. So the first environmental assessment area is project management, which gets 10%. We encourage written performance goals to be created by the team and owner group to be set at pre-design, so at the very beginning while you're thinking through your project. And that would include site design, environmentally responsible construction activities, water conservation, a building envelope and moisture control, evaluation, energy efficiency, materials, and indoor environment, all to be considered. So that's at infancy. We also require building risk assessments to be done, which would identify risks to the building, including continued building occupancy resulting from extreme natural events. So we want to look at global climate change, human activity, and the expected service life of the building. We also look at environmental management practices during construction, and if an emergency management system is in place or if it needs to be in place. And project teams can also elect to perform a life cycle cost analyses that would demonstrate a building service life plan. And these paths are weighted equally in terms of points. So we really try to encourage looking at the whole building and its life cycle. We also award credit for performing a moisture control analysis. Again, we look at environment that might be more prevalent in areas like Florida. And project teams can choose either building commissioning and training pathway or a systems manual and training pathway. You don't have to do all of the above. Okay, so this is just an example. I tried to find what project this is from. David, maybe you might know. I was looking out the window. It almost looks like New York, but I couldn't quite tell. An ECHO-Charette meeting with the building owner and various disciplines are critical at the beginning of design, as I mentioned, as they can dictate the sustainable vision for the entire project and life cycle of that building. The owner has functional goals for the project, of course, and that's based on the building type, the location, and their budget. And it is important to incorporate sustainability goals by weighing cost and the different benefits of the design elements that they're considering. Okay, so the second environmental assessment area is site. The first section of site is the development area, which evaluates various aspects of site selection, including consideration of urban infill and urban sprawl. Project teams are incentivized to choose a site that was previously developed and has been served by existing utility and transportation infrastructure, a brownfield or remediated Superfund site, and avoiding sensitive sites and different floodplains. If you build on a floodplain, that might be a little bit of an insurance disaster. Transportation includes distance and feasibility to public transportation. And obviously, we're looking for methods that reduce dependency on single occupancy vehicles. I mentioned I work in policy. For whatever reason, 2021 was the year of EV charging stations throughout the country. Every state wanted to have different charging station laws that went into place during legislative session. So we were really happy to see that it's not just in certain areas like California and Utah that are very advanced in their different energy efficiency laws, but also down south where I live, we're also seeing a lot of EV charging stations put in place, which I'm quite proud of. All right, construction impacts evaluate the measures used to minimize disturbance to the surrounding site, the protection of existing trees and shrubs, mitigating heat island effects with vegetation, shaded or high SRR roofs, and permeable surfaces that would address bird strikes. All right, so this is just a great example of someone putting a green space on their roof. We're currently doing some work in Boston right now, and one very cool thing that they're doing is putting different beehives on a lot of buildings. So there's a portfolio that's building out, and they have beehives on each. So folks are getting really creative with the way that they're working with their space and using their roofs, and obviously we're quite proud to see that. A heat island effect can contribute to overwarming, of course, and buildings in warmer months, adding to considerably to the cooling load, which increases the energy efficiency use and the energy use. So we really like to see things like this. All right. The third environmental assessment area is energy. I mentioned at the very beginning, this is what is most heavily weighted, and there are 3 pathways for assessing energy performance. Path A would be using ANSI ASHRAE IES Standard 90.1 2010. Again, if you're in an area that has a higher 90.1 standard in place, you still get full credit for just meeting 2010. We want to see folks go above code, obviously, but you would be rewarded a full 180 points. Performance path B would be building carbon dioxide equivalent emissions, which would also get you that 180 point threshold. And path C would be more prescriptive for lighting controls, HVAC equipment, hot water heaters, and other systems. Non-modeled energy efficiency impacts are also evaluated. So think of things like elevators, escalators, and moving sidewalks if applicable. Lighting and HVAC systems capable of load shedding, appliances and equipment organized by location, and energy-saving power strips and occupancy sensors are all looked for as well. Additionally, credit for the implementation of a policy for all purchased equipment to be ENERGY STAR certified or meet another equivalent energy efficiency standard is awarded. Projects earn credit for a percentage of building's total site energy that is metered through building level energy meters, and there are 3 pathways for achieving credit for submetering in this assessment. We also look at both on and off-site renewable energy sources in the energy environmental assessment area. Okay. So in the example projected on the screen, submetering was used in each tenant space to inform occupants of the rate of energy use and to incentivize them to reduce energy on demand. Generally, if occupants are made aware of how much energy they are using and paying for, they're more likely to conserve it. This reminds me of being a little kid and my mother telling me to turn off all the lights after I leave the room. Do you guys? Yeah, okay. I'm glad you both experienced that. All right, the 4th environmental assessment area in Green Globes for new construction is water efficiency, which is right behind energy for weighted. It's 19%. Water conserving fixtures, including WaterSense certified plumbing fixtures and ENERGY STAR appliances with low water factors, are always encouraged, as are cooling towers, boilers, and hot water systems, water intensive applications, including commercial food service equipment, laboratory and medical equipment, laundry equipment, water features, and pools if applicable. Water treatment methods, alternative sources of water such as gray water and rainwater are also looked for, and submetering for all water-intensive indoor applications and portable water used for irrigation are also looked for. Credit is earned for meters and submeters that are linked to a meter data management system to meter consumption. All right, so we actually awarded this project a Green Globes Award in 2021. It's quite unique, and they harvest all the rainfall in the ponds that you can see, and those are used to provide 100% year-round irrigation for flushing toilets, which is very cool. All right, the fifth environmental assessment area is materials. Green Globes really encourages lifestyle thinking from project conception. The first section evaluated is whole building life cycle assessments, and it evaluates reductions in environmental impact. Projects receive credit once 15% reduction in environmental impacts are demonstrated and can receive credit for 20 points or at least 25% for greater. Product life cycle is next under materials. We look for third-party verifications or certifications that evaluate cradle-to-gate product life cycles. Credit is also earned for sustainable material attributes based on the Sustainable Materials Index, or SMI, and the reuse of existing structures and materials are also evaluated as a percentage of structural systems and non-structural systems that are on the interior space. Okay, and the example above, all wood materials used were third-party sustainable forestry certified. In this case, the columns and beams are laminated timber made from certified wood products. So you can see those on the decorative guardrail. All right, the building on screen was also built in the same space as the last picture, and it was on land that had a building. It was a warehouse that had been burnt down, and they used what land was destroyed and built up this structure that you see here. Many portions of the pre-development project were salvaged and reused and incorporated in the new building design. The partial facade of the previous building was used as a screen for the on-site parking area, and actually this is in Portland, Oregon. They managed to save all of the graffiti because they wanted to give the building character, because they gave the space new life after that fire. All right, the sixth and last environmental assessment in Green Globes for new construction is the indoor environment. Air ventilation and quality are the quantity of ventilation compliant with one of 4 standards or local codes. Air change effectiveness, air handling, equipment filtration, and CO2 sensing and ventilation control equipment are also evaluated in this section. Source control and measurement of indoor pollutants include evaluating and encouraging reduced volatile organic compounds, and there are 2 paths for achieving credit for pre-occupancy indoor air quality testing. So either carbon monoxide monitoring or evaluating if water systems have been conformed with ASHRAE 188-2018. Lighting design and systems are also awarded and encouraged. Think of things like daylight. I remember when I first got into efficiency, circadian lighting was like the buzzword. So we really encourage lighting designers to have their footprint on the space as well. And we award for that. We also look for thermal comfort zones and non-acoustical privacy and comfort zones, including noise limits and sound metering. High ceilings and high windows allow daylight to penetrate deep into the space. In this example, lighting controls that automatically sense daylight levels, brighten when the sky grows dark and dim, and when the sky brightens as well. These controls reduce the need for artificial lighting and thereby reduce energy consumption. I work from home. I have a home office. We went fully virtual in 2013, and I do not have this type of daylighting, and I so wish I did. All right, so this is just a nice example to show from design review to receiving your Green Globe certification. It normally takes 4 to 6 months to bring a new construction building through Green Globe certification, but that excludes the design and construction of the space. And while we look at square footage for pricing, a new construction building that wants to go through Green Globes normally is at a price point of about $14,000, which is quite low compared to other certification systems currently at market right now. So we offer a few different resources through GBI. Every building that goes through Green Globe certification is awarded a project profile. So we have a professional writer that comes in and authors a piece about the space. We also photograph it and we use it as a marketing tool, and this is free of charge. So it's really something that's unique. Folks will often use it if they're in a university system or if they're sharing in a community what they've done on a whole portfolio. We really want to try and encourage them to take advantage of what we can do. If you're curious, we have a lot of our different buildings that have gone through certification for new construction on our project profile directory on our website, and you can tailor it for different certification types or area. So if you wanted to look at Utah and see some of the work that's been certified, you're welcome to do so. And again, we have a certified building directory as well. So if you're just curious to see the different buildings, I just looked at North America, specifically the United States here. However, we do offer, different ways to check out the buildings that we've certified and if anything around you has been certified as well. I mentioned our fee structure, but again, it all depends on square footage. And really what we see now, I checked again this morning, it's right at about $14,000 to certify through Green Globes for new construction. You can see here that we have a design review assessment and final assessment. We have something called a Green Globes assessor, which is someone that has 10 plus years of experience in engineering or architecture, and they work with the project teams through certification. And what I think is really cool is when they're doing these design review assessments, they often can point out what project teams can do to be more resilient, more efficient. They can, definitely suggest different changes so that building types can do as much as they can to achieve optimum energy savings. So it's really something that is quite collaborative. And then we definitely send them out. That assessor travel is something that we have as a flat fee, and they come out and do that design assessment at the very end and work with the project team. So we don't expect folks to certify in a black box. We really encourage them to be as collaborative as possible. Our client service team at GBI works with every project very, very closely, which David can attest to. And so it really is a collaborative process. No one's alone in certifying. You have either your assessor who you can contact, and they're normally familiar with a different space, or you can work with GBI directly through our client service team. All right, and I did just want to mention, we have a few different professional credentials and membership options. So we offer a membership structure, which is a cornerstone of the GBI. Our members are very, very involved at GBI. We have different opportunities for them to work with things like our government engagement committee, or if they're more interested in working on different things that we have in-house, we encourage them to be involved. We also have different perks for them, discounts on project registrations, obviously members only pricing for different events that we have. So we have a pretty large membership entity at GBI. In 2023, we're also rolling out a municipal membership. So if you work for a state and you want to get more ingrained, it's $45 for every person who wants to join. And what we're offering is every 6 to 4 weeks, we're going to have, I say 6 because I want to make sure that we can get this planned, but what we're going to do is we're going to have different municipalities meet, and they're going to be able to talk through different things they're rolling out. So for example, I'm working with the city of Indianapolis right now. They're creating a tax abatement. This is the first time the city's ever done that. We're able to connect them with the state of Nevada, who's also had a tax abatement and was sunsetted a few years ago, but they can learn from different municipalities. So if you work for this state, or if your team wants to learn what other folks are doing throughout the United States, this is a membership option that we're really excited to roll out next year. We also have different credentials that I mentioned. We have the Green Globes Emerging Professionals, which we normally see a lot of students and interns pursue, and it's a very low price point. We have the Green Globes Professional, and we have the distinct honor of a Green Globes Fellow. And those are folks that have worked in this space for quite some time. All right, guys, thank you so much. I'm gonna make sure that David doesn't mind joining me. We're gonna run through a quick question and A because he is one of our Green Globes assessors. But if you have any questions that you'd like to ask David and I, please feel free and we can tackle those together. Ready? I won't put you on the hot seat too much.
I need to make sure, is this working?
Okay. All right. How did you get into the green building profession, and when did you begin working with GBI?
Oh, so that's a great question. So I got into the realm of sustainability while I was actually in college down at Arizona State University. They had a great program, and as part of our tuition, they let us choose a conference to go to nationally that they would send us to. I went to the ASHRAE conference when it was in Vegas and followed their sustainability track, and I just loved it and have stuck with it since then. So it's been a great experience. And then my experience with GBI, the second part of your question. So every once in a while, it's a rare occasion, but GBI will reach out to the public and say, hey, are there any potential assessors out there who are interested in helping us out? And I don't actually remember how I got on the mailing list. But
We're very lucky that you were a part of that mailing list.
But I was, and I was interested, so I reached out. At the time, I was working on a lot of federal projects, and so I was going through the guiding principles compliance stuff instead of the main Green Globes compliance. But yeah, that's how I got into it.
That's great. So I didn't talk too much about Green Globes assessors because I wanted to leave that for our conversation. So in your words, what is a Green Globes assessor, and how do you interact with project teams that are going through certification?
Yeah, so for those of you who know me, I enjoy teaching, and GBI is kind of my outlet for that professionally. As an assessor, when you're going through the certification process, you have direct access to me to answer any questions that you have about sustainability in general and GBI specifically. That's what differs GBI from a lot of other certification programs. And so every time I get a phone call or an email, I have the opportunity to step into that teaching role, right, and really explain why certain things are important in sustainability, why GBI focuses on it, and why potentially the points system is weighted in that way. So I enjoy being an assessor because of that.
Yeah, and it is unique because we don't have prerequisites, which other folks do. So that lends itself to some differences too.
Agreed, yeah.
So you work with communities that vary in size. And so I think a lot of times folks get intimidated if they're in a rural or small area to bring their building through Green Globe certification or a LEED certification. It's just not as prevalent. What do you say to that? Have you worked with communities that vary in size in some more rural areas?
I have. I'll take my state of Utah hat off for this one because most of my experience in this realm has to do with my work in the private sector. And I think every project that you work on needs to have sustainability entrenched in not only the process of designing it, but also in building and the occupancy of it. I'm working on a project in Hyde Park, a small soda shop where they're reusing shipping containers, which is great. And we're working with them right now post-process to add solar panels into their design as well, so that they can operate even when the grid is down, right? And the owners have been really receptive to that. We found actually, especially in the private sector, that there's a thirst for sustainability. How can I help? How can I be a part of this movement? Because people understand that it's no longer just about a plaque on the wall, right? It's about their children and their grandchildren and what they're going to leave behind.
Yeah, I see that too. I think folks are really engaged and they want to learn more. That's been something that I've seen more recently, and it's exciting. Can you speak to the rigor of Green Globes compared to some other green building rating systems?
Yeah, I think for the most part it's more rigorous than other certification programs because they go through the ANSI process. So Emily mentioned that earlier. I don't actually believe that LEED goes through the ANSI project because they want to be able to make decisions on their own without necessarily listening to the public. That goes along with the International Living Future Institute as well. They don't go through that process. And there are pros and cons to both. They can make changes faster than GBI can make changes, but they don't get input from everyone, right? There are a few people who are pulling the strings. And so what's great about GBI is the holistic approach that they take because of the public input that they receive and the process they follow in order to get ANSI certified.
Yeah, I agree. I think that's one big difference. I mean, we're rolling out this net zero protocol and it's not quite ready for market just yet. But one of the things we're doing, we're working with subject matter experts like David to really get input before we bring something to market and folks are not able to achieve a net zero building or a net zero protocols or portfolio rather. So that's something that we take very seriously. Okay, here's a fun one. What do you think the future of green building looks like in Utah and then also in the United States? And I asked you this before the Senate bill just hit, so there's some advantages there, but not thinking about that, what do you think about Utah and US?
Wow. So in Utah, there's always room for growth. I'd love to see Utah do something similar to tax abatements like Nevada has implemented in order to not only, because the market wants this, right? But it's with the tax abatements and things like that, it hits the bottom line.
Sure.
So it helps everyone benefit from it, right? Even the hardline businessmen who are like, if it doesn't make me $1, I'm not doing it. Well, in this case, sustainability can make you $1, so do it. So it really brings everybody to the table instead of just those who are currently interested in sustainability. And then I think nationwide, so we know about Biden and his approach that he's taking. What was the name of that bill? Is it?
Oh, it is
Inflation Reduction?
It's the Inflation Reduction Act, but it was changed from the Build Back Better Act. So it's a form of what they adopted from the Build Back Better.
Yeah, I'm really excited about that and the opportunities that it's going to bring to the sustainability sector and the built environment specifically. But it's too early to really tell how it's going to help and how much it's going to help. So I'm watching that one. Hopefully you are too.
Yeah, absolutely. The Biden-Harris administration also has a group of 30 different state and local municipalities that have to achieve different benchmarking and building standards performances. So they're bringing a lot of communities through that right now, which is exciting to see how every different jurisdiction is approaching this in a unique way. So that's something that I'm also very encouraged by and excited for. Okay, so the last 2 years have been rough. The pandemic has really shaped us individually and as a nation. How do you think the pandemic has influenced what we know to be a high-performing building?
Yeah, so COVID, for one, in some ways has been at odds with sustainability because it took us a little while to figure it out, but COVID is an aerosol, so it's transmitted through the air, not through touching surfaces. So early on when we learned how to wash our hands, that was a good thing, but it wasn't necessarily preventing the spread of COVID.
Yeah.
And so what most people have done, there are several different things they've done, and it has to do with their mechanical system because it's aerosols. And so the level of filtration has increased. The amount of outside air in some cases has also increased, and that's at odds with some of the energy saving goals that we've had in the built environment for quite some time. And so it's been a balancing act of how much filtration do you add, what type of filtration do you add, and then how much more outside air are you going to bring in to make sure the occupants of your building are healthy, right? The buildings are built for occupants, not for energy efficiency.
Right.
So we first and foremost want to make sure that the occupants of the building are safe and are in a healthy environment. And then we want to look at energy savings. So a lot of that has to do with eliminating, for instance, I'll use the University of Utah's approach to this effort. So they increased their filtration to where their standard filtration level is a MERV 13, which the higher the MERV number, the better their filtration. They stopped short of adding UV lights in most of their buildings to filter the air because they didn't feel like, one, that it was a large enough benefit, and two, it would cost them more than the benefit they would receive. But they didn't use that across the board, though. There are some, like hospital facilities, where it's where you have a lot more germs that are transmitted through the mechanical system, where they have specifically added multiple forms of filtration in those circumstances. As far as the amount of outside air they bring in, they're looking at upgrading the efficiency of their dedicated outdoor air systems on the mechanical side of things, to make sure that although they want to bring in enough air, but they want to make sure they're doing it in the most efficient way possible.
Right.
And so that's the balancing act that the way they've balanced things on campus there. Every institution is kind of taking their own approach to things like that. So it's been interesting to watch.
Yeah, I know. I love when project teams are running with their different approaches. I'm not really able to get in the technical nitty gritty. So anytime they're doing that, I'm always asking our team, like, what's this group doing? Because it's so cool.
Before we move on,
Yeah.
I want to mention as well, something that COVID changed for the Green Globes is that typically on a project, the assessor actually goes out to the site and inspects the building, which does two things. One, it verifies that things are actually done. And two, it limits the amount of documentation that design teams are required to do in order to prove that they're being sustainable, because there's someone getting their eyes on the building. During the pandemic, unfortunately, that switched to virtual, which thankfully we have technology that helped us do that. It's not ideal though. So I think now we've gone back to in-person assessments on site. And that's something that really differentiates GBI from other certification programs.
Yeah, being adaptable. We also changed the questionnaire that project teams go through when they're certifying. It's our criteria broken down in a question set. So it's very, very easy to go through, and we allow every member of the project team to have access to that questionnaire. So it's a very collaborative process. So while they're going through certification, not only do you have your assessor on hand, you have the GBI team on hand to help you, you also can call on different folks that are a part of your project team to help guide you through that certification, so you're not one person in a silo, which I think is very beneficial as well. Okay, so you mentioned you have a university or had a university that was very encouraging of your sustainability career. So if someone was just getting started in sustainability and they were trying to learn about what was out there, what advice would you give to them other than being a GGEP with GBI?
Yeah, another great question. You have a great question.
Thank you.
So the great thing about the world of sustainability is that there's room for everybody and anybody, right? All personality types, all different types of background. That's one of the reasons why I love the sustainability community so much. Everyone has a place and everyone gets a voice. And so if you're interested in getting involved in sustainability, there is, in the built environment, there's the Green Globe. What is for students?
Emerging professional.
Emerging professionals. The GGEP with Green Globes. But really, because the sustainability world is there for everyone, there are different avenues depending on where you want to go. Mine started in school, right? My kids actually have friends that come over and chat with them about interesting topics, not all of them about sustainability. But when it goes to sustainability, they just basically have impromptu conversations about things like that, right? Like, man, mom made me turn off the lights today. Oh, well, that's important because, and so it could be just forming a group with your friends and getting together every once in a while to chat. Or it could be more formal, such as an education or going with a certification that GBI might have. So if you're interested, come find me and we'll figure out what you're interested in and what the best path forward might be for you.
Yeah, I'm here to help too. Okay, our last question, and then we can open it up just in case anyone else has questions for us. I want to know about Utah. So like, what's happening at a Utah level that you're just like jazzed about, that you're very excited about, changes that you're seeing that you're just encouraged by?
Yeah, so I'm going to put back on my state hat now and talk a little bit about what the state's doing. So the first thing that we're doing, and is based on a COVID response and teleworking, is that we want to save the taxpayers money. And because so many people are working from home now, that means we have a lot of office space that's being underutilized. And so a lot of our effort currently is combining different departments into buildings, consolidating them basically, and getting rid of leases that we no longer need, all that extra square footage. And it's interesting to come up with new ways of using office space as well. For instance, we'll have QR codes on every desk. And you walk up to the desk, you scan your QR code, and you check that desk out for the day.
That's great.
Right? So you don't have permanent office space. Then that's on the space utilization side. On the high performance building standard side, the state has done really amazing things. We just updated that standard February 2021. It actually is one of the most rigorous standards in the U.S., especially when it comes to air infiltration and building efficiency. So air infiltration is how leaky the envelope is, right? How much air either can leak out or can seep into a building. And the requirement from the state is that it has a 1.1 CFM per square foot tightness requirement for the envelope. One of the toughest in the nation. It's almost as strict as Passive House, if you're familiar with that program. The other thing is we shifted recently from ASHRAE 90.1 2010 baseline for energy analysis on our new construction and existing buildings over to an EUI target. EUI is an energy use intensity, and it's on an energy per square foot per year basis. And so now we're not tied to a specific year of a standard, or we don't have to stick with or update our requirements every year based on what new standard has been updated. We have a target that is set, and then that building has to meet that target, whether it's going all electric, whether it's mixed fuel, or whether it has other more aggressive energy goals as well. So we're super excited to see that happen, and to implement more aggressive water savings.
That's awesome. I don't know if I mentioned this, but what we normally see is energy policy moves from west to east and then down south. So we're always watching the Californias and the Utahs and the Nevadas to see what they're doing, because it's a sure sign that that's going to be trickled over and adopted and modified for every different jurisdiction. So it's been a real joy watching what Utah's done. Okay, perfect. Does anyone have any questions for David and I? No? Okay. Well, if we have no questions, I think we're going to take a break. And then we're going to have a 10-minute break, Jacqueline says. And then we're going to hear from Brent, our code official, on hand. And then we're going to have lunch. So thank you guys so much for the time. I appreciate it.
Thank you.
Good afternoon. Appreciate the opportunity to be here and to talk with you. I am going to start out, we have a relatively small group here, and I'm going to ask everybody to introduce themselves so I know the group I'm talking to. Now, I know some of you, I recognize lots of faces, but I think it's beneficial for everybody if I know, who I'm talking to.
Roger Gross, I'm an architect.
Okay, no architect jokes then, right?
I'm Braden Barado. I am the construction project manager.
Go ahead.
Dave Griffin, I'm the Assistant Director of Facilities for the State of Utah for Building Performance and owner of Griffin Energy Consulting.
Very good.
I'm Aaron Hoskington, real estate broker and developer, and was a general contractor, but right now it's more as a consultant to projects.
Okay,
Bill West, the general contractor.
very good, Bill. Jacqueline?
I am Jacqueline Brickler. I work for Resource Innovations, and I am the program manager for the Utah Energy Code.
Okay, and our people over here from the state?
Yeah, my name is Claire. I'm in the Utah Office of Energy Development and help sponsor the Building Trust Program, and co-manager Utah.
I'm Joseph. I'm a program specialist with the State Energy Program and also with the
I'm Karina Olson with the Office of Energy Development.
Very good. And these three young ladies here are one of the reasons I'm here. In fact, if you don't know, and I think most of you do, excuse me, my responsibility right now and why I'm here is I'm the Energy Code instructor, mentor, resource, whatever, in the state. And it's for about 10 years now, I have taught Energy Code classes across the state and given direction and help when someone has a question on Energy Code. And we have what we call the Building Talks program that OED manages. We are funded by Dominion Energy, Rocky Mountain Power, Department of Utah Office of Energy Development, and Department of Energy. And so those of you that, and most of you know this, if you have a question on the Energy Code, and I have builders call me and contractors call me virtually every day, you have a question, a plans examiner's asking you to do something and you don't think that's right, or you just want some clarification, feel free to get a hold of me. I am trying to go to working generally just 2 or 3 days a week, so an email or a text message is best by far, because well, I'm not going to tell you exactly how old I am, but I started in HVAC 50 years ago, and so I've been working in basically building thermal envelopes for 50 years, because what's the basis of HVAC? A load calculation, so you know what you need to put in that building. I love it. I have a passion for it. I'm excited to to meet Emily and to hear a little bit more about your Above Code program. And it's just great to be part of the process. I just want to acknowledge, and everybody should be aware of this, if you have a question about the Energy Code, sometimes you can just go to energycodes.gov and you can find answers. We also have a utahenergycode.com website that we have blogs and we have videos and everything, and we can get some answers there. So we have a lot of resources. And of course, this website is where you can download ComCheck and ResCheck. Why do we care about the IECC or ASHRAE, the Energy Code? Why do we care? Energy codes and standards set minimum efficiency requirements. I get a little frustrated sometimes because I end up, over the last 12 years, spent some time up at the Utah legislature when we are considering adopting codes, and I've served on committees that have reviewed the codes. And there is a certain segment in our population that thinks our energy code is the latest and the greatest, and we shouldn't force that on people. They could They shouldn't have to build that efficient building. Well, my problem with that is, you know, I'm in my fourth house. My house that I'm doing improvements on right now, someone is going to live in that house, and they are going to be paying energy bills based on how my house is built. And so the idea that, well, I'm going to build a building, whether it's a commercial building or a residential building, and I'm going to pick what I'm going to do because it only impacts me, isn't true, because it impacts everybody, the next owner. But today in our valley, you're fortunate it's not February when you're here, because we have a horrible pollution problem when we have inversions come and set in here. And so how we build our buildings, everything we do, anything that we burn, anything that adds to, you know, our pollution is a problem for us. And right now, what's our other concern? And you've mentioned this, it's water. And water and energy are tied together like this. In fact, the energy code is moving down that path, that water is a component of the energy code. We spend so much money pumping water and having to deal with water. And when we spend that money, it's for electricity to move that water. So it's not an aggressive code, our energy code, it's a minimum code. And I'm thrilled when I see above code programs. We want to reduce energy use and emissions over the life of the building. It's a subset of the building codes establishing baseline requirements. It's not overly aggressive. And more important to me, and I think we touched on it a little bit earlier, number one reason we build a building is to keep the rain off our head and to be comfortable. And we don't want to take away from that, but we can do that by building an energy efficient building, and we can have a more comfortable building and a cost-effective building to operate. There are some significant differences between IECC and ASHRAE. I'm going to basically talk IECC, International Energy Conservation Code, and then I'm going to jump in and just identify some of those significant differences. But overall, it's building science, it's thermodynamics. How does heat flow in and out of a building? How does air flow in and out of a building? How do we move air in and out of a building to maintain air quality? And so neither one of them has a different science, it's the same science, and they're very similar in nature. Okay, my soapbox, and Carl and others that have heard me talk before know that I will jump up on a soapbox and I'll say our biggest problem in building buildings efficiently and accurately is to have complete construction documents. And I love the process that you have to go through for Green Globes, because we make sure, and there's checks and balances. I've done inspections. For those that don't know, I was a HVAC contractor for 33 years, and then I was a building inspector for 13 years. And I've done inspections, and I get to the end of the building, and the windows are wrong, or the HVAC system has some deficiencies, and it's all done. And whether it was the ME or the architect or the contractor, someone made a mistake along the way. And if we don't have good, complete construction documents, and that's not just the plans, but it's all the associated documents. In fact, you have a whole list, and I think I grabbed that slide and maybe even have it in here. If we don't address all those things, our project is not going to be the project we want it to be. As a contractor, there literally were jobs that I wish when I was approached to bid that job that I'd written them a check for $10,000 and said, go get someone else to do it, because everything was wrong with the project. The documents weren't good, the supervision was horrible, everything was poor on the project. And so the project was just a pig that everybody lost money on. And so it might look like a lot of steps you have to go through, but they're so important. We're bringing hundreds and thousands of people together to create this building, and if we don't have a plan and a process, we're not going to get it right. So, in short, what I'm trying to say is, if we have U factors, we have R values, we have solar heat gain coefficients, we have all these different thermal performance metrics that we use to measure. And if they're not identical on the plans and the specifications and the energy compliance documents and the design calculations and all the other documents, how do we get the building right? You know, it says we want 0.32 windows here, and then we end up over here it says 0.38, and which one do we end up with? I know when I worked for government, if I went on our final inspection on a 18-story building and said, hey, your windows are wrong, you got to change them all, that's not going to fly. That's when politics really plays a big role. So consistency in all of our documents and our processes is so important. And here's your list. And I highlighted things that I look for. You know, I've done some third-party plan review. I still do some since I retired from the county. And these are all the things I look for, you know, and they're on your list and they're on my list. These are important things. Balancing reports for ventilation systems, you talked about that. You know, we have this challenge, and you two were talking about it with COVID. And some people went overboard and brought in way too much outside air. And the systems couldn't handle it, and the equipment couldn't handle it. And so we have to be a little bit careful on that. And in fact, bringing too much outside air is just wasteful. So we have balance points all over the place. We have to spend some energy for comfort and health. And we have to be mindful that the energy code recognizes that and doesn't get too rambunctious on that. What I'm trying to cover today, I could take 2 days, so I'm just going to go real quick. Structure of the IECC and the structure of ASHRAE is not that much different. IECC is divided into 2 sections, a commercial and residential section, and they are like any other code. We have Chapter 1 administration, 2 definitions, 3 general requirements, 4 kind of the meat and potatoes of the code. And then fortunately, a couple of code cycles ago, we were able to remove existing building requirements and put them in a single chapter. So if you're doing that building remodel or alteration, you have one place you go to and you identify what you have to do rather than trying to piecemeal pick it out of the code. When does my building need to comply with the commercial provisions? And we're talking a commercial above code program here. And as I looked through your slides and watched, you have certified or recognized a lot of apartments. Well, is an apartment residential or is it commercial code? Well, ASHRAE is the one that started this. You know, by 90.1 is for commercial buildings except low-rise residential. And so by definition, for both ASHRAE and IECC, a commercial building is any building other than a 1 and 2 family residential building, Rs 2s, 3s, and 4s, 3 stories or less in height. Let me simplify that because most of you don't know what an R2, 3, and 4 is. Basically, a hotel and motel is an R1. Every one of them is commercial no matter what. The 2s, 3s, and 4s are apartments and boarding houses and stuff like that. If they're 3 stories or less, they have to comply with the residential code. If they're 4 stories or more, they have to comply with the commercial code. 1 and 2 family residential, of course, that's residential building. And people will say, well, what about townhouses? Townhouses are single family dwellings with a 0 lot line. So they always fall under the residential. So we're talking the commercial. But our commercial can get a little bit interesting sometime because it's very popular right now to build a 1, 2, or 3 story building. And sometimes we have some retail and some rental units on the same level, or we go up to 3 levels. Well, if you have that building 3 stories or less below grade, you do those levels that are residential dwellings out of the residential energy code, and you do the retail space out of the commercial code. And it gets a little confusing, but oh well. I'm not going to read this whole thing, but this is one of those things that I fought for in code development that I thought needed to be there. And the beauty of above code programs is that they give you some options and some flexibility. Well, the code is not intended to be the only way you build a building. And the fact the code says this, we're not trying to prevent using a different method. All you have to do is submit it and get it approved. Well, for a long time, I had people call me that wanted to do something a little bit different. They submitted it to the jurisdiction, and the code official will say, nope, I'm not going to accept that. And they say, well, why not? And he says, because I said so. Does that sound like what my mom said to me years and years ago, because I said so? The code now says that if the code official doesn't approve that, he has to state in writing why he or she doesn't approve that. And I think that's a good addition to the code. Here's the code identifies all these things that should be on our documentation. And you notice some red. That means that we are in, that is a new change in the 2018 code, which is the last code that we adopted. And there is a big push on our larger commercial buildings now, and the code has recognized it, that we need building documentation, we need commissioning and all that stuff, and it needs to be submitted as we finish up the building. And also that we identify the thermal envelope. I have to throw in a word about the building thermal envelope. We have comm checks, we have, ASHRAE has, you know, Appendix G, they have a number of methods that you can comply with the code, but every one of them looks at the thermal envelope. What separates conditioned from unconditioned space? And we talked earlier about air leakage, infiltration. Well, we need to identify on the plans now that where that air barrier is, where are we stopping air leakage? And so that's an important thing that we think about. Don't build a building, pressurize the building, find the leaks and go fix them. Let's identify where it is so that we know what steps we have to take as we move through. So how do we comply with the code? We can use ASHRAE 90.1, and currently in Utah it's 2016 is the adopted version. Or we can use IECC, and we can basically go the prescriptive approach, and we're going to talk a little bit about that. And when we do that prescriptive approach, you go through, you comply with everything, and then when you get finished, you have to pick one additional efficiency feature. And we have a whole list there, and we added 2 more in 2018. And so we have, I think we have 8 of them now. This is a perfect place for that alternate method. You don't do this in Georgia, but here, how can we cool a building, and what do we see on our great big buildings? We see indirect and direct evap cooling. And you can save tens of thousands of dollars in energy costs by having that 2 of your stages in your system. Virtually every great big building I see built right now in the last year, 5 to 10 years, has a chiller, but also has an indirect cooling coil that hooks to the cooling tower that you can just circulate water through, or it has a media where you can do direct evaporative cooling. And they're big savings, aren't they? They're huge savings. Facebook has built a couple of big buildings out in Eagle Mountain, data centers that are almost 1 million square feet, 100% evap cooling. That is saving hundreds and hundreds of thousands of dollars a year on those buildings in energy cost. But the code doesn't recognize it. So this is a perfect example where someone could submit, we are going to do direct and indirect evap cooling on our building. Give us a few, a little bit of documentation, this definitely would qualify as an additional energy efficiency feature. This is kind of a baby step towards, let's do a little bit, where really we should do a lot and do what you're doing and what you're doing, and step up. And let's not just go a 15% step. Let's pick up more. So anyway, that's the way the prescriptive side of the IECC works. And then we have the performance side, which is modeling, and we have, you get all finished with that, and you need to be 15% more efficient. So, and we could talk for hours on any one of these. So our additional options, real quick, more efficient HVAC. We have tables in the code that say we need to have certain efficiencies depending on the type of mechanical equipment. So if you want to select that option, then you have to step it up. Reduce lighting power density for the systems. How many watts per square foot? Well, go a little bit further. This used to be, well, it still is the easiest way to comply because the code is still a little bit behind on LED technology. I have received lighting comm checks that passed by 50 and 60% because the code was written for the use of high pressure sodium and all these different lights before LED was so affordable. And so that's an easy one, and that's the one that most people select. Enhanced lighting controls that shut down lights and occupancy and all kinds of different features. On-site renewable, of course. Dedicated outdoor air, which was mentioned. We need to bring in some outside air. Dedicated outdoor air systems, are you using ERV or HRV or some type of system that you gain efficiency? More efficient service water heating. This is only available for uses that use lots of hot water. Hotels, motels, maybe some schools. It's not available for everything. So every one of them has some qualification requirements on it. Enhanced envelope performance, which means you're going to test the building and come with a lower leakage. Oops. And reduced air infiltration, which are both new in the 18 code. So what is the thermal envelope? It's the roofs, the walls, the fenestration, skylights, floor edges, slab edges, below grade walls. I had an apartment project, it was like 6 stories high, submitted for review. I sent it back and I said, you need to put every component of the building thermal envelope on the comm check document. And they had left the floors out. It was a podium slab, parking underneath, multi-family apartments on top. And he hadn't done anything for those first floor units that had cold space underneath, cold concrete, cold slab edge on the edge of that. And finally I called him up and I says, this is the 3rd time and you still haven't addressed it. And he says, I can't. And I says, well, why can't you? If I put it in, it won't pass. I won't say exactly what I thought, but you can guess. Of course it won't pass. You left out an important component of the thermal envelope. Comm check or any system doesn't know what the building looks like. You have to put in what the building looks like, and you have to put in all of the components of the thermal envelope, or it's not right. We don't get the right building. So with that type of application, we have a problem because we have a slab edge that's really hard to insulate, and a floor underneath that's kind of hard to insulate. But we need to be thinking about it, and I'm just tickled to death because I started on the code enforcement side in 2005, and we really struggled with concrete buildings, tilt-up buildings, and CMU and all those things. And I'm seeing so many tilt-up buildings now that they're sandwiching foam between 2 layers of concrete, a structural layer and then just a cladding layer and structural foam, and it really makes a great envelope. It doesn't leak air at all, and it has mass, and it has good insulation. So we are making progress. It's just taking a little while to get there. And so how do we comply with the IECC? We have either an R value based or a UC F factor based or a component modeling approach, which, and I mentioned this at the first, prescriptive covers the first two, the R and the U. And then we have some very specific requirements for roof reflectance and fenestration limits and air leakage. But, so here's our options. And we have similar options in ASHRAE. You have an R value table. And I know you can't read it. And in fact, if you want a copy of my slides, send me an email. My email address is at the end. And you pick your climate zone and you just meet that requirement. Or you use a U factor table, which uses U factors instead of R's, the inverse of one another. And it tells you what you have to have. Notice I have a comment there, supporting calculations or documentation is required. R values are pretty easy. What's R value that we put in the cavity? You can't just do the inverse of, say you put R19 in that wall, you can't go 1 divided by 19 and get the U because you have the studs that provide some thermal bridging, so you have to come up with assembly U factors. When we use the term U factor, we're looking at an assembly, and we have to account for everything in that assembly. And so with a U factor table, you have to have supporting calculations or documentation to use that table. So the next few slides I'm going to touch on. And actually, the third option is the performance alternative, and I put it on the wrong slide. That's modeling. But I have some ComCheck things that I want to talk about, and so forgive the wrong title on this. So here's a ComCheck that was submitted that I reviewed, and I whited out the project because some of you might recognize it. They did pick an additional efficiency package, and it was dedicated outdoor air system, which means they were providing ventilation air efficiently, and then they have to show how they do that. Now here's where it gets really interesting. And I don't know how well you can see this, but the top line, the top assembly is roof number 1, and it's about 7,000 square feet, and they say the cavity has R19, and there's also continuous insulation of R19. There was one R19 bat in a metal building roof system, and they double dipped and tried to, they didn't obviously know what they were doing, which shows a building that's really going to perform great because continuous insulation has what? No thermal bridging. It works very well. So that was a problem. We come down to the exterior walls, and it says 19 in the cavity, R5 continuous insulation. Many of you know this, continuous insulation is insulation that is only penetrated by a fastener. So foam, it could be rock wool that has a fastener. As soon as you put Z-girts or studs or something, it turns into cavity insulation because we have that thermal bridge that can conduct heat in and out of the building. I highlighted it because the plan didn't show the R5 on the plans. Exterior concrete block wall, medium density, probably not medium density. I don't remember for sure. It might have been heavyweights. But anyway, again, they had R20. That means someplace they had 4 inches of pink foam or something, but they didn't have that there. Drop down to the next one. And if you don't understand why this is a problem, you will shortly. Window, metal frame, fixed, U factor 0.2. Can I go out and buy a metal frame window with a U factor of 0.2? Jacqueline's nodding her head, no. You paid attention in my class, didn't you? I taught Jacqueline about 5 or 6 years ago, right here in this building. They don't make right now a window that performs like that. That is an R5 window. That's a great window. To get a 0.2 U factor, you're going to need something like fiberglass frame and triple glazing with argon and stuff like that. You just can't get a 0.2 U factor on a metal frame window with current technology. If you can, let's get together, let's find some money, and let's make some windows, and let's make $1 billion. Same thing as we go down. An uninsulated single layer metal door with a 0.41 U factor. I don't think so. Then they have other metal building wall, 0.2 U factor. Soon as you see other in a comm check, if you'll notice footnote B, other components require supporting documentation. It goes back to the thing. We just can't pull a number out of the air, throw it on a document and say it works. I love the process that you go through of having these checks and this verification as you go through. Fenestration products must be certified. And then, of course, whoever's stating that it complies needs to sign it. Now, this comm check passed by 6% with the ridiculous number for windows and double the insulation in the ceiling. So there's no way that this would have complied. And this is one of those things that we're having to make some decisions on. Skylight area and window areas, we have hard limits set in the code. You can, like one of them is 3% skylight area. But then all of a sudden we now say in the code, you can have 6% skylight if you have what? If you have daylighting controls that step your lights on and off according to how much light's coming through. So it's where the code is looking at both sides of the issue. Natural light is great. We don't need to have all those lights burning all the time. And so the code's doing that in many areas. So I told you we were going to talk about windows. Fenestration, which is anything we put in a hole in a wall or a roof. It's a window, it's a door, it's a skylight. That's fenestration. The code in ASHRAE, well, ASHRAE is code. The codes all say that we need to have some type of documentation. If it's a manufactured window, you're going to have a sticker on it like in the middle. And it's going to give you a U factor and a solar heat gain coefficient and a VT number, air leakage and condensation resistance numbers. It's going to give you that because they built the window according to a certain process and it's been certified that way. And it's rated in accordance with NFRC. If you do site-built windows like we have right here in this space here, then we have to come up with a way to identify what the U factor is for that entire assembly with aluminum frames. And so NFRC has a process in place where we can have those windows, someone analyzes the windows, the window frames and everything to come up with that. And they have a software and everything. I'm not going to go into detail on it because of time. But in combination of all those components, we can get a certification. And then over here on the right, a certification for that site-built product would be completed. So what does the code say? And I bring this up just real quick, and I'm going to point out that if you look at the middle column, Climate Zone 5, which is where we are right now, fixed fenestration, so that's a window that doesn't operate, is fixed like these right here. If you want to use a prescriptive table, you have to have a window that has a 0.38 U factor. Now, the lower the number, the better, the higher, the worse. So it's the inverse of the R. So you have to have a 0.38. If you're in Climate Zone 6, which is colder, then you have to have a 0.36. If you're in Climate Zone 3, and those 3 columns are what we have in Utah, a 0.46. So in St. George, the U factor, you can have a little bit less. But in St. George, we have to have a better solar heat gain coefficient because of the sun and the heat gain from the sun. So anyway, remember the number 0.38. Now, I've used Conair aluminum frames in this presentation because they have great data that's available online, but it helps drive home. And this was something we really struggled with 10 years ago. The architect does a good job specifying that we have to have a 0.38 or 0.40 window. And then the window guys say, well, no one's going to check, and so they put, in this case, 451 frames, which don't have a thermal break. So we have that thermal bridge where the heat can easily flow in and out of the window. We have 451T, which is thermal break that has a single piece of nylon polymer, some type of material, to give you a thermal break. And then we have the 451UT, or ultra thermal break, that has double thermal breaks to stop that heat flow and to drive the U factor down where we want it. So I take these frames, then I go to a manufacturer, and this is Vitro, formerly PPG, and you can go to these tables, and you will see, and this is for the IGUs, those insulated glass units, which you have right here, 2 panes of glass, a spacer, sealed, maybe filled with argon. And they say for center of glass, what the U factor right in the middle of the glass is generally 0.28 for all of these Solar Band 70 products. So it has a 0.28 U factor. Well, the code says we have to have a 0.38. That's great. We're better. We haven't taken into account the frames because we have a lot of heat flow through the frames. So Conair takes it a little bit further, and I hope you can read it, but anyway, if you take that 0.28 glass that we just saw on that previous chart, put it in their standard non-thermal break frames, you have a U factor of 0.47. So it almost doubles the heat flow through the whole assembly because the frames are so poor. Now, anybody that's ever lived in Utah in a house or worked in a building that has aluminum frames that aren't thermal break know when it gets cold, you have frost and moisture dripping and everything running off of it. So if we go a single thermal break with that 0.28 glass, we're 0.39. We're still 1/100th off of hitting the code minimum. So we haven't met the code. And so if we go to 451 UT with that great glass and a good frame, we barely drop below that 0.36. Where you really get in trouble is when we have a large custom contemporary style home that wants to put storefront type glass in it because the residential requirement is 0.32 and you can't reach it. So it's really a challenge. All of these things, the above code programs say, do not override, you comply with the basic code. You have to still comply with the basic code, and then you exceed it. They also have a table where you just pick this center, the COG of the glass, and the frame. This is a UT, and it tells you what your U factors are. So if you have really good glass that's 0.2, you can get down to 0.3 on the overall U factor. If you have questions, give me a holler. Now please.
With regard to that, those U factors are window U factors are predicated on essentially temperature, is that correct?
The question is there.
To the flow of heat,
The U factor directly impacts the flow of heat.
then how, is there any accommodation then given for the fact that you have differing exposures? There are 3 purposes that I know of, maybe 4 for a window. It is access for egress, and it is for view, for ventilation, and
light, VT.
So if as an architect, or you then vary that where you have a southern exposure, where you might have a prevailing wind and all kinds of things, you put a baffle or an eave or a host of light, heat reducing elements outside of the window. Why does that only hold, that was still holds, you don't get any credit for that?
So, great, that's a great question. The question is, what about the direction the window faces, if you put some overhangs, if you do some shading on it? And actually, I kind of screamed through it, but if you look further down in this table, so the upper one is U factor. Now, U factor just looks at conduction, conducting the heat to and fro. And so we don't care which one it faces, because we're going to look at the solar heat gain coefficient, and we see we have south, east, and west, and north. And then we also have on the far left, it says PF, projection factor. And so this does account for it. And I really prefer when I do this slide that I put in a diagram that shows projection factors and everything. But you're right on track. You're absolutely right on track that it's there. Now remember, this is a prescriptive discussion. You can trade some of this off. You can do some things, and maybe you have a big window that doesn't quite make it, but you can make up for it someplace else. And as I see it, your program allows that too. These above code programs and modeling is starting more and more to recognize we look at the whole assembly, we look at the whole energy use for the whole thing, and we account for it all. Someone can build in St. George a building with a great view of the Red Rock with a horrible window if they do a whole bunch of other stuff to offset it. So that's a great question. Thank you. So while I was on that solar heat gain coefficient, and I should have said that. So SHGC, solar heat gain coefficient, I'll just grab one. It says southeast and western climate zone 3, you have to have a 0.25 if you have a projection factor less than 0.2. What that 0.25 means is 25% of the heat in the sun rays make it into your building, 75% gets reflected out. So that's the importance there. You can see different ones. Look at north windows. We really don't care so much about north windows. Why? The sun never hits them. I had to throw this one in because it's just really, really cool. One of my boys is a senior building engineer for Cushman Wakefield for the southwest region of the United States, and he has like 70 million square feet of building that he's in charge of. And one of the buildings that he worked in put in dynamic glass. Has anybody ever seen dynamic glass? This stuff is crazy expensive, but it is so cool. They put this in a building and took 60 tons off the chiller size. Now, when you look at life cycle costs and everything down the road, when you can drop 60 tons off your chiller size, you know, maybe this crazy expensive glass isn't such a bad idea. And this glass is literally controlled by your BMS, your building management system, and it can darken, increase the solar heat gain coefficient on the side that the glass is facing. So it gives you that overhang, the effect of an overhang, as the day progresses. And it's really cool I have some pictures of it. They didn't come out as good as I'd like, because as the sun moves across the horizon, it starts with the east and then a little bit on the south and then the west glass. And it literally darkens by putting electrical charge on a film that's between the panes of glass. So anyway, those are all the same glass. The one on the right is taken to level 4. The one on the left is somewhere around a standard window, and you can go anywhere in between. I even see these ones that darken completely occasionally on a home up in Park City that has a great view and everything. They put them around the bathtub so you can have the view all the time, but you hit the switch and the window is your blind. So they have a U value as an assembly around 0.29, but their solar heat gain coefficient starts at 0.41, so 41% of the heat comes in, and at full darkening, only 0.09 or 9% of the heat makes it into the space. So it's a really cool product, and hopefully, just like everything else, it'll do like LED light bulbs did. You know, it'll become so much more affordable. I bought some LED light bulbs for my, I was doing a remodel on my house, and this was like 10, 11 years ago, and I wanted 4 little tiny can lights in a coffered ceiling I built. I think I paid $37 a piece for these little LED lights. I mean, it's crazy what I paid. But, and why can I get them for now? A couple bucks. Okay, so all of the codes require you comply with the envelope, your mechanical systems comply, and your lighting and electrical systems comply. The mechanical, and this is virtually my only slide, well, I have 2 slides. These are all the things that the code addresses, from economizers to multi-zone and VAV and exhaust and heat rejection. These are big cooling towers. In fact, this is on the Adobe building down around the point of the mountain. And outside the building. When do we heat outside? There's a driving range down here at Mulligan's. Anybody know where that is? Just over here on 104th. I just live up past that. And they have little heaters that in the wintertime you can turn them on over those colored canopies. They have to have controls that it doesn't stay on. It has to be a timer or occupancy sensor. We could spend 2 days on that. New in the code are guest HVAC controls and ventilation controls. We have requirements for walk-in freezers, coolers, all those things. Commissioning, those all apply to all mechanical systems. And we also have new in the code, can you heat and cool a vestibule? Finally been addressed in both. You can, but you have to shut it off when you get to 45 degrees outside as far as heating, and you can't heat above 60 and you can't cool below 85. You defeat the purpose of a vestibule when you start heating it. You know, it's supposed to be a buffer. We just talked about water. And I wrote an article that's on the website about this very thing, and I grabbed these pictures. You ever been to a big hotel for a convention and go to the restroom and try to wash your hands in warm water, and you never get warm water? And that's because they have low flow faucets and they have ridiculous designs in their piping. And some people are really upset about this, but you look at this option 1 diagram on the left, we have a 2-inch line going across, and you probably have a recirc pump on it, so you maintain hot water in the 2-inch line. But then we have a 1-inch line going down, and then it branches off to the 6 sinks or labs. I did a calculation on this one, and it was like 100 and something seconds to flush the cool water out so you had hot water down at your sinks. That's never going to happen. And so what the code has identified is you need to limit the length from your source. And so we see down below, I'm sorry you can't see it very good, but you run the pipe down so it's shorter. What's one of the other solutions? And it's probably, when you do your energy model, a better solution is at source water heater. A little small water heater under that row of sinks, rather than a pump that's circulating hot water through a 2-inch line that's maybe insulated but maybe not very good, and a great big water heater that's holding 200 gallons and everything. How much water do we need to wash our hands? Almost nothing. And so those are some of the things that the code does. How many have stayed in a brand new hotel motel room lately and had to put the card in the thing to get it to work? Yeah, I just went to Texas a month or 2 ago, and they gave us 3 cards. Here, just put this one in the thing on the wall so it's on all the time and bring it back, you know, completely defeats the purpose. The idea is, I just have it on the heating, but it's also on the electrical. When you leave, we shut stuff down. So what's in the lighting? I'm supposed to be done at 1. Close? I'll be close. We have all these lighting requirements, controls, wattage limits, lighting power allowances, which is just basically how many watts per square foot. Really easy to meet with LED lights. Dwellings need electric meters, and you were talking about that. Exterior lighting allowances, motors and transformers, vertical and horizontal transport systems, or elevators and escalators. You know, escalators now need to have regenerative braking because of, you know, when the elevator's going down and all the braking it's doing to keep it from running away. So real quick, I'm just going to touch on some ASHRAE stuff. The number one complaint I hear about ASHRAE right now is you have to have 50% of your convenience receptacles switched. So when you leave, it shuts off. You're supposed to plug in your monitors and all that stuff in there, so we shut stuff off when you leave the space. This is in private offices, conference rooms, and so on. And 25% of it's modular. There's a lot of resistance to that. Well, guess what? The 21 IECC, it's in there, so it's here. We had some changes. ASHRAE changed in the 2016. They're 2 years different than the IECC. And we had some climate zone changes. If you look at Utah, probably can't see it very well, but if you look up on the upper right one, Box Elder County switched from climate zone 6 to climate zone 5, northwest Utah. And we had some changes in Texas, quite a few changes in Texas, and we're probably going to have some more. So as with the IECC, we have prescriptive where you can meet the tables, or you can do a comm check, or you do an energy cost budget, which is, I'm going to call it the early version of modeling. And we do have Appendix G that you talked about, which is a more flexible modeling system performance rating method that looks at the beyond what the previous performance modeling. Lots more flexibilities, time saving, encourage, you know, creation of tools that automate the simulation process as the market increases. Provides credit for good design practices. So with Appendix G, you get credit for basically anything that impacts the efficiency. Other big thing, and we're just about there, that ASHRAE provides a positive for the builders and the designers is that with ASHRAE, you can have what we call a semi-heated space. So you can have a warehouse building with offices that you have to meet the full requirements of the code, but the back space that you're just tempering is a semi-heated space, and we have reduced efficiency or insulation requirements for that space. So that one's an advantage for big warehouse buildings. And then I wanted to talk on floor insulation real quick. And I've had my thermal camera out and looked at some projects that really had poor performance, especially in floors. And that's because if you look at on the bottom right here, the top diagram, we have a floor system with conditioned space above. We have the insulation set down on a lid underneath it, an airspace in there. What happens to that airspace if we're not insulated around the perimeter? The airspace is cold, right? It makes the insulation ineffective because we've just turned that space. So what we have learned, well, we've known it, but we're really starting to focus on is our air permeable insulation needs to be enclosed on all 6 sides. We're up tight against roof decks. We have an air barrier underneath it. The best way I can describe this is we put on a sweater. If there's no breeze, it gives us warmth. If we have a slight breeze, air movement, what happens? The air goes through it. And how effective is the sweater? The R value goes towards 0. So we need to make sure our air permeable insulation, our fiberglass bats, our blown insulation, all that stuff is enclosed on all 6 sides. We have those air barriers. And that's it real quick. Any questions? Very good. I think we'll eat lunch. Thank you. Oh, and I have a prize here for the gentleman that asked a question. It's a little coaster for your desk, and it says, I support